Hello, Honors Algebra 2. It is Thursday, April 30th, last day of April, and we are continuing on in chapter 15 with combinations. And so I wanted to quickly show you how you can find your program or your function for combinations. Y'all probably would figure it out without me, but just in case, I'm going to go ahead and show you. It's going to be just like our NPR, but it's going to be NCR. And this is a combination. We'll learn about what that is in a second. But let's say we're going to choose 6 items and do a combination. So I'm going to go to math and I'm going to go over to probability, and we'll see down here below the permutation function is the combination function. So I'm just going to hit number 3. And let's say I want to do a combination out of 6 items. I'm going to choose 2, and of course you press enter. So that's where your combination function is, right below your permutation. So now let me go ahead and change my sharing to my iPad, and this will just take a sec. And so here we go. My screen is locked. And I'm going to mirror, and here we go. Ta-da, ta-da. Okay, so here we are, and we're talking about combinations. Well, before we do that, I want to go ahead and talk about subsets. So let's go ahead and talk about subsets. What is a subset? Well, where is my pen? My pen. I'm on erase mode. It always happens. A subset is a set of which all the elements are contained in another set. So let's go ahead and write all the subsets for the 3-letter set PQR. Well, let's list all the subsets we use. Oh, that was a pretty bad brace there. Excuse me. We could one subset would be P. Another subset would be Q. Another subset would be R. Another subset would be PQ. We separate them with commas. What else do we have? We have PR. We have QR. And we do not list them as, if we have a subset PR, we don't list it again as RP. The order does not matter. We're just listing what elements would be in a subset of PQR. So there's also, every set is a subset of itself. So PQR is actually a subset of itself. And then we've got what we call the null set, So there's 1, 2, 3, 4, 5, 6, 7, 8 I should have, and I have 8. Okay, so there's a subset. What about 2-letter subsets? Well, 2-letter subsets would just be PQ, PR, well, bad again, and QR. All right, so you'll have a few homework problems where you have to list subsets. Now, we know that the order of the letters does not matter. The order of the letters in the subset does not matter. Okay, now, combinations are very similar to subsets. A combination is a selection of items from a group such that the order of the selection does not matter, just like the order in the subset does not matter. Now, with permutation, order does matter. So let's look at some examples so you can tell the difference. A combination would be selecting 3 students out of 10 students to be on a committee. So I could select Abby, Joe, and Pete. But if I select Abby, Pete, and Joe, or Joe, Pete, and Abby, it doesn't really matter what order they're in. They're just a group of 3 people that I'm going to have on a committee. So the order in which I select them, or the order in which they're on the committee is not a big deal. They're just a general group of 3 people on a committee. Okay, now, what is a permutation? That would be selecting 3 students out of 10 to have specific roles as president, vice president, and secretary. Because it would be one thing for, let's pick Joe to be president and Sally to be vice president, or Sally could be president and Joe could be vice president. So the order matters. There's a special position in this group of three, the second group of three, a special position as president, vice president, and secretary. So order does matter there. But picking a general group of three students, you would not care about the order. You're just picking a general group of three. Let's look at another example. A combination would be selecting a 5-card hand out of 52 cards. Now, does it really matter the order in which you hold them in your hand? If you have an ace, 2, 3, 4, 5, or if you have them in your hand as a 5, 4, 3, 2 ace, or an ace, 3, 5, 2, 4. It's just a general group of 5 cards in your hand. The order doesn't matter. But what's a permutation where the order would matter? Selecting 5 students out of 20 to line up for a photograph. You could have the shortest student on the left. You could have the tallest student on the left. You could have the girl with the blonde hair in the middle, or the girl with the blonde hair on the far right. So there is a special order to arrange the students when you're lining them up for a photograph. So order matters. That would be a permutation. How many ways could I order 5 students out of 20? Okay, let's move on. Now, we already know our formula for permutation. You take the total number of elements or objects in the numerator factorial, and you divide it by n minus r being how many you're selecting out of the total n elements in your denominator, the difference of n minus r factorial. Now, a combination is going to be a different formula, but it's very much like the permutation formula with the addition of this r factorial in the denominator. Now, let's look at this example on 1 and 2 here, and then we'll see how the formula works with those. If I'm going to choose a group of 2 letters from the letters A, B, C, and order matters, let's go ahead and list those options. I could select A, B. I could select A, C. I could select B, A. Okay, order does matter, so A, B, and B, A are different. And I could select B, C. I could select CA. I already have AC, but CA is different. And I could select CB. I already have BC listed, but CB is different. The order is different, and it matters. Now, if we made that a permutation out of 3 letters, I'm choosing 2. Our formula would be 3 factorial over 3 minus 2, which is 1 factorial. And I have 3 factorial is 3 times 2 times 1 is 6. And of course, I have 6 possible arrangements. Now, if order doesn't matter, what would my groups of 2 letters be? AB, same as above, AC. Now, can I list BA? No, because it says order doesn't matter, and AB and BA are the same group of 2 letters. Let's go to BC. I don't have those 2 grouped together. All right, the next would be, excuse me, CA. I already have that in the form of AC. And then CB, I already have that in the form of BC. Now, let's go ahead and use our new formula. This is a combination because order does not matter. That would be out of 3 letters. I have a combination of 2, which would be my n, or my 3 factorial. Now I'm going to include my 2, my r factorial, and then my n minus r factorial. Whoops, I forgot the 1. Okay, so that means I've got 3 times 2 factorial over 2 factorial, 1 factorial. Well, that all cancels out, and what do I get? 3. And of course, I have 3 here. So it works. I just add the r factorial to the denominator. Now, excuse me, let's go ahead and find the number of combinations of the letters in the word solve if we're going to take them 5 at a time. So how many ways can I have a group of those specific 5 letters if order doesn't matter? Well, let's go ahead and do a combination of 5, choose 5. Well, I have 5 factorial. Now I'm going to divide by my r, which is 5 factorial, and my n minus r is 0 factorial. So what do I get here? Remember that 0 factorial is 1, so my answer is 1. There's only one way to have a group of those 5 letters. That's it. And we knew that, but we're just using the formula to test it. All right, we want to choose 2 at a time, a combination. All right, so this time we have 5 letters, a combination of choosing 2. So that's going to be 5 factorial over my R, 2 factorial over the difference, 5 minus 2, 3 factorial. Well, I'm going to go ahead and write that as 5 times 4 times 3 factorial over 2 factorial, 3 factorial. And I've got 5 times 4 is 20 divided by 2 is 10. You can use your calculator, but sometimes it's just as fast, if not faster, to just work it out yourself. And we've done this before with the binomial theorem, and y'all did great with that. Okay, let's go to the last page. Now, this can get tricky. This can get tricky. So let me say this. When you are in probability and the combinations and permutations, always the word and will mean to multiply, and the word or will always mean to add. Okay, so just remember that in permutation and combination and also in probability, those are going to be, those words are going to translate into those operations. Now, in how many ways can a committee of 6 be chosen from 5 teachers and 4 students if A, all are equally eligible? Okay, so what that means is I'm just going to not worry about whether they're teachers or students. I'm going to go ahead and make a committee with a general group of 6 are going to be chosen from a total of how many people? 9 people are chosen. 9 people to choose from. That's 5 plus 4. 9 people are chosen. And I'm so sorry, 9 total to choose from, and we're going to take 6. Sorry. Okay, so out of 9 people total, doesn't matter what their role is, 9 people total, teachers or students, we're going to choose 6. Now I'm going to go ahead and use my calculator here. You can hear probably me hitting my little buttons here. I'm going to do 9C3, and I'm going to get 84. There are 84 possible committees of 6 people formed. Now, let's go make it a little bit more difficult. What if we have a committee that has to have exactly 3 teachers and 3 students? Well, there's your word and. And what did I say and meant? Look at the top, it means to multiply. So what we're going to do first is figure out of 5 teachers, we're going to do a combination. We're going to find how many groups out of 5 teachers can we get a group of 3. I want to get, out of 5 teachers, I want to choose 3 to be on this committee. And out of 4 students, I want to choose 3. Okay? Now the order doesn't matter. So we're going to go ahead and use combination here. There's no special job for any particular one. These are general groups of students and teachers. All right, so let me go ahead and use my calculator here. I've got out of 5 teachers, I'm going to choose 3, and that is a value of 10. And then out of 4 students, I'm going to choose 3 of those, and there's 4 ways I can do that. Okay, and so what is the number of ways that I can choose a committee with 3 teachers and 3 students? There are 40 different ways I can choose that committee where I have exactly 3 teachers and 3 students. Okay, now let's go to the deck of cards. Now, if you're not a card player, you may have to pull out a deck of cards, but there are 52 cards in a deck. There are 4 suits, okay, clubs, diamonds, hearts, and spades, and there's 13 cards in each suit. 52 divided by 4. How many 5-card hands? How many 5-card hands can be dealt that include 4 cards from the same suit and 1 card from a different suit? All right. So I see the word and, but there's also something else going on here. So what if I would include 4 cards from the same suit? The situation, or what makes it complicated is I could have those 4 cards be clubs, or they could be diamonds, or they could be hearts, or they could be spades. Alrighty? So I've got 4 different options here. And remember, or means add. So what are we going to do here? Well, the first thing we're going to do is we are going to think about how many. Let's take one suit at a time. There are 13 cards in one suit, and we want to have how many from one suit? We want to have 4 from one suit. So how many ways can I get a group of 4 cards out of 13? Okay, so this 13C4 is how many groups of cards I can get from one suit. But I have 4 suits to choose from. So since I could do one or clubs or diamonds or hearts or spades, I'm going to take 13C4 and multiply it by 4. I could add them all. I could do 13C4 plus 13C4 plus 13C. Okay, I could do it that way, but I'm just going to multiply by 4. Okay, so I'm basically adding 13C4 4 times. Okay, because that is the number of different ways I could have 4 cards from the same suit. And, okay, and what else do I want? I want to get 1 card from a different suit. So the first thing I have to think about is how many cards, if I had 4 cards from one suit, okay, my first 4 cards are from one suit, how many cards would be available to me from the other 3 suits? Well, that would be 52 minus 13. And 52 minus 13 is 39. So now what I'm going to do is I'm going to say my other card is going to come from a group of 39 from the different suit, and I'm only going to choose 1. Okay, so I want to get 4 cards from the same suit, so I can do clubs or diamonds or hearts or spades, and I want to get 1 card from a suit that is different from whatever the first suit is. So now let's go ahead and figure this out. I'm going to go ahead and put 4 here. Let's do 13C4. 13C4 gives me 715. And then 39C1 should give me 39. Yep. And let's multiply 39 times 4 times 715, and I'm getting 111,540 different ways I could have 4 cards from one suit and 1 card from another suit. Okay. Now, you're going to have some problems like that on the homework, and so go back over that example. It's in the book. And lastly, let's try this one because there's one like this in the homework too. How many 7-card hands could have exactly 3 spades, 3 clubs, and 1 heart? Okay, so notice that with this 3, and this 1, that's going to give me the total of the 7 cards. So how many, let's start with the spades. Out of 13 cards that are spades, I'm going to select 3. I want a group of 3 spades out of 13. And out of 13 clubs, I want 3 clubs. And out of 13 hearts, I want 1 heart. So let's go ahead. I'm going to go ahead and choose that. Oh, I did that wrong. Okay, 13, choose 3. I've got 286. And then I'm going to repeat that because that's going to be the same thing for the clubs. And then 13, choose 1, should be just 13, and it is. Just double checking. So let's multiply 286 times 286 times 13. And I get there are 1,063,348 excuse me, ways to get 3 spades, 3 clubs, excuse me, and 1 heart. All righty, so that's a little bit more complicated, isn't it? If you need help, come to Zoom in the morning at 10 and I will be there. But both of these last two problems should be able to help you with the B problems today on the homework. They're very similar. So I hope you have a great day. This is not due until Monday. So I'll see you at Zoom or talk to you again on Monday. Bye-bye.